This is the fourth section of the circles chapter, and this is on using tangent and chord properties, and this comes from GCSE and your circle theorems. So you may have forgotten all about those, and you may think, well, I'll never use them again. Well, they've popped up again here. And your circle theorems are going to help you with these questions. Now, one of the circle theorems says that when you have a radius and a tangent, which we've got here, and a radian meets a tangent at a right angle. Okay, so there are some things that we can glean from that, use from that. So the first thing is that they're perpendicular. Okay, perpendicular. The line of the tangent and radius, which means you can be using this minus 1 over m. And also, not only are they perpendicular to each other, the tangent meets the circle at a single point. So where we have this tangent, remember when we combine the equations, that b squared minus 4ac is going to be equal to 0. So that's something else as well that we can apply. The second circle theorem says that if you have a chord of a circle and a line that bisects that chord, then that line will go through the center of a circle. Another way of saying it is that if you have a line that goes through the center of a circle and it meets a chord, it will bisect that chord. So what have we got going on here? So we've got this point here, which is the midpoint. Yeah, and we've done a section on finding midpoints of lines. So you should be thinking x1 plus x2 over 2 for the x coordinate, and the two y coordinates added together over 2. So you've got a midpoint there. We've got this chord, which is meeting at 2 places. And we know that with a chord, if we combine the equations and we work out b squared minus 4ac, it's going to be greater than 0. Yeah, so all these things that we've learned from before, we can apply to these circle theorems. Okay, a circle C has equation. Let's underline that equation. That verify that the point 10, 0 lies on C. So all we need to do is substitute 10, 0 into that and see if we get 100. Okay, so at 10, 0, we've got x equals 10, y equals 0. So we'll substitute those in. So we'll get 10 minus 2 squared plus 0 minus 6 squared. We want to see what that gives us. So it's going to be 8 squared plus negative 6 squared, which is 64 plus 36, which is 100. Okay, so we've just verified that it goes through that point. Yeah. So P is on the circle C. Part B. Find an equation for the tangent to C at that point, giving your answer in the form. So it's the equation of a straight line, and they told us they wanted it in that form. So before I go any further, I'm going to draw a sketch of this circle. It just helps me in my mind visualize what's going on. Let's do a better circle than that. There we go. So there's my circle. This point P lies on C, so we've got a point P. Let's do it down here. And we want to find the equation of this line here. Okay, this tangent. and this point here is 10, 0. I know this is not actually to scale or on, you know, done right, because that tangent really should be the x-axis. But you know, for our purposes, it's just a sketch, just to sort of help us out, to sort of help us visualize what's going on. Right, so if I want to find the equation of that tangent, I really need to find the, like this, don't I? Yeah, because I know these are perpendicular. So maybe I either need to know this point here or the center, and I think I can find the center from the equation and the radius if I need it. Right, so let's start by finding the center. I'm going to use the center point and the point 10, 0 to work out the gradient of that line there. So I'm going to work out m basically for that, and then use -1 over m for this. Okay, so start by finding the center. So center of C is, I can just read off those coordinates, 2, 6. Okay, I'll just put the gradient of the radius, and I'm going to call that m, is, so I'm basically trying to find the gradient between the points 2, 6 and 10, 0. So if I do 10 minus 2, whoops, sorry, not 10 minus 2, I want to do the y coordinates, don't I? So I'll do it the other way around. So 6 minus 0, so that's the change in y, over 2 minus 10, so keep the order the same. So it's going to be 6 over -8, which is -3/4. Okay, so therefore the gradient of the tangent is 4/3. Yeah, the negative reciprocal of the radius, so that's going to be -4/3. So now we can use, so using y minus y1 equals mx minus x1, because we now know the gradient and the point that it passes through, and the gradient passes through the point 10, 0. So it's going to be y minus 0 equals m 4/3 x minus x1. So that's going to be 10. And it's told us what form we need to leave it in. So we'll rearrange everything so it's in that form. So first of all, expand the brackets. So y equals 4/3 x minus 40/3. Bring everything to one side. So you've got 4/3 x minus y minus 40/3 equals 0. Now normally when you leave it in this form, you leave the values of a, b and c as whole numbers. So we're going to multiply everything through by 10, and we'll get 4x, sorry, not by 10, multiply everything by 3. So we get 4x minus 3y minus 40 equals 0. Yeah. So yeah, normally when you leave it in that form, ax plus by plus c equals 0, you'll leave a, b and c as integers. So there we go for that one. Okay, so we've got the equation of a circle here. That. The line L is a tangent to this circle and has gradient -3. Find two possible values for L, giving your answer in the form y equals mx plus c. So I'm going to draw a sketch again. like sketches, so I can see what's going on. So I've got a line which is a tangent to this circle, so it's just touching at one point there. And the gradient of this is -3. And this is going to involve the radius, because I can work out the center of the circle, and that is going to help me work out possible values for the equation of this line. Now the reasons why it said find two possible values or two possible equations for L is because all we know is the gradient, and we can have a line that's parallel to this over here, which is also a tangent, yeah, which is also going to have the same gradient. So this is why there are two possible values or two possible equations for this line L. Right, so these are the steps I'm going to take. So I'm going to find, first of all, the equation of the diameter, yeah, because I know its gradient and I know a point that it passes through. After I've found the equation of the diameter, what I'm really interested in are these points here, yeah. If I can get those points, I can then work out the equations of the tangents. So the second thing I'm going to do is to find where the diameter, or find the points where the diameter meets the circle by solving simultaneously. And then once I've found the points where the diameter meets the circle, they're those red points there. Next, I'm going to use those points to find the equations of those possible lines. Okay, so once I've found that, so use these points along with the gradient of L to find possible equations for L. Right, so there are the steps. So step number one is going to be to find the equation of the diameter. Now the center of the circle, we should be able to just read off from the equation, is the point 5, -3. The gradient of the diameter, well, it's going to be perpendicular to the gradient of the tangent, so that's going to be 1/3. Okay, so now I can find the equation of the diameter, because I've got its gradient at the point that it passes through. So using y minus y1 equals m x minus x1, I get this. That can be tidied up to give y plus 3 equals 1/3 x minus 5/3. So if I take away 3 from both sides, I end up with y equals 1/3 x minus 5/3 minus 3 is minus 14/3. That's the first step done. The second step now is to find where the diameter meets the circle. So that means solving simultaneously this and the equation of the circle. So I'm going to substitute y for that 1/3 x minus 14/3. So sub in 1/3 x minus 14/3 for y, so it's not particularly nice. If we do that, we'll get x minus 5 squared plus y, not y, we're subbing in, 1/3 minus 1/3 x minus 14 over 3 plus 3 all squared, and I'll bring the 10 over as well, minus 10 equals 0. So it's not particularly nice, that. Right, so tidy up a bit, x minus 5 all squared plus 1/3 x. Now, negative 14 over 3 plus 3, it takes us back to minus 5 over 3 again. So minus 5 over 3 all squared minus 10 equals 0. Right, let's expand the brackets. Right, so we'll get x squared minus 5x is minus 10x plus 25 from the first bracket. The second bracket, we're going to have to be careful with this one. A third x times a third x is 1/9 x squared. Now this is where I'm going to need my calculator, because I'm going to have minus 5 over 3. That's going to get times by a third. Times by a third. That'll give me minus 5 over 9x minus another 5 over 9x will give me minus 10 over 9x, and then I've got minus 2/5 times by minus 2/5, which is going to be plus 25 over 9 minus the 10 equals 0. Right, let's see what we can do with that. So we've got x squared plus a 9th squared, so that's like a 9th, 9 ninths plus another one, so 10 ninths x squared. Keep things as improper fractions, just a bit nicer. Minus 10 minus 10 ninths, let's work that out. So minus 10 minus 10 over 9 will give me minus 100 over 9. So minus, oops, in black, minus 100 over 9x, and then the last bit here, you've got 25 plus 25 over 9 minus 10, so 25 plus 25 over 9 minus 10, and that gives us 160 over 9, so plus 160 over 9 equals 0. First thing, multiply everything by 9. That's going to make it much easier. So 10x squared minus 100x plus 160. Right, divide everything by 10. So x squared minus 10x plus 16 equals 0. So two numbers that multiply to give me 16 add to give me negative 10. So those two numbers have got to be 8 and 2. So that will factorize to give me x. Let's think. Negative 8, negative 2. So the solutions are x equals 8 or x equals 2. Right, so what we've got now is we've got the x coordinates where the line meets the circle, or the points on the tangent, those two red dots that I've marked. We now want to work out the y coordinates. So the first y coordinate, we substitute these x coordinates back into here, to work out what a y coordinate. So that's the easiest way to work them out. So that's going to be a third times by 8 minus 14 over 3. I've worked that out already, that gives you negative 2. If I substitute the 2 in, so a third times 2 minus 14 over 3 Let's do that. So I'll just scroll back and change the 8 to 2, and I get the other coordinate as -4. Right, so let's just take stock of what we've done before we move on. I have worked out the points where the line meets the circle. One point here, its coordinate is 8, -2, 8, -2, and the coordinate of the other point over here is 2, -4, 2, -4. Right, I can now use those coordinates along with the gradient to work out the equations of this line. So we're almost done. So let's call them L1 and L2, L1, L2. Right, so line number 1, using y equals, or y minus y1, y minus y1 equals m x minus x1, right? And then for L2, y minus, now we've got a different coordinate, y minus y1 equals m, same gradient, x minus x1, and we're going to leave these in the form y equals mx plus c. So we'll have y plus 2 equals -3x plus 24. So that gives us a final answer of y equals -3x plus 22. And down here, y plus 4 equals -3x plus 6, which will leave me with y equals -3x plus 2. So these are my final answers down here. I'll write them a little bit bigger at the top because it might be difficult for you to see. So final answers, y equals -3x plus 22, or the other value, same gradient, but a different y-intercept here. Right here we've got the points P and Q lie in a circle, so this is nice. We've got a diagram already drawn with centre C as shown in the diagram. The point P has coordinates -7, -1, that's already drawn, and the point Q has coordinates 3, -5, again already put on there for us. M is the midpoint of the line section PQ. The line L passes through the points M and C. The line L read that already. Part A, find an equation for L. So L, the line L, is perpendicular to PQ, so we can find its gradient, and it passes through the midpoint of PQ. So let's just write that down, part A. So L is perpendicular to PQ and passes through the midpoint of PQ. So we need to find two things, the midpoint of PQ and the gradient of PQ. So midpoint of PQ is, well, it's going to be -7 plus 3 over 2, and then -1 minus 5 over 2. So that leaves us with -2 and -3. Okay, so that's that midpoint M. Let me just put that on the diagram there. -2, -3. Right, now we're going to find the gradient of PQ. So we are going to look at the change in the y coordinates. So let's do -1 minus -5 over -7 minus 3. So that will give me -1 plus 5, which is 4 over -10. So it's minus 2/5 is the gradient of PQ. So now we're going to use y minus y1, which is going to be -3, equals m. Now, all right, the gradient of L, almost got called out here, gradient of L then, gradiento, new word, gradient of L is going to be 5 over 2. I almost got caught out there. So 5 over 2 x minus x1. Right, it doesn't say what form, it says find an equation, so you can leave it whatever form you like. So I'm going to leave it as y plus 3 equals 5 over 2 x plus 2. Yeah, there's nothing that says you need to change it, so that's absolutely fine. That's the an equation of the line. My part B says, given that the y coordinate of C is -8, show that the x coordinate of C is -4. Now, we can use the equation of the line, yeah? And all we need to do is to substitute in y equals -8 and see if we get x is 4 or -4. So we just sub in y equals -8 into the equation of this line. So that will give us -8 plus 3 equals 5 over 2 x plus 2. So that gives us -5 equals 5 over 2 x plus 5. Then we'll take away 5 from both sides. We've got 5 over 2x equals -10. So from there, we will have x equals -10 divided by 5 over 2, or times by 2 over 5, and we get -4. Okay, so that's proven as required. Okay, part C says find an equation of the circle. So we have the center of the circle. So we got half of what we need, and the center is -4, -8. We got that from the last bit. So what we need now is the radius of the circle. Now the radius of the circle is the distance from the center to any point on the circumference. So for example, that is the radius. Yeah, or I could even use this as the radius. And I know the center is -4, -8. So I can use that along with one of those coordinates and find the distance between those coordinates. So I'm actually going to I'm going to do radius, I'm going to use the point P. Radius equals the length between P and C, so that can be written like this. These two little bars either side basically means the length of, and the way we're going to do that is we are going to do Pythagoras on those two. So we need to find the difference between the x coordinates. So that's -7 minus -4 and square it. plus the difference between the y coordinates, that's going to be -1 minus -8. Let's miss the minus out, minus -8, and square that and see what we get. Right, so -7 basically plus 4 is -3. So you've got -3 squared here. Then we've got -1 minus -8, which is like -1, plus 8, which is 7. So we've got 7 squared. Okay, so that's going to be the square root of 9 plus 49, which is going to be 58. Okay, so the radius is 58. So if I want the equation of the circle, that's just going to be x minus -4. So I write x plus 4 squared. So remember, I'm using this here, center, and I'm using this radius here. Then the other bit is going to be plus y plus 8. Remember, it's like y minus -8 squared equals the radius squared. Now if I square root, square root of 58, I get 58. So this leaves as the final equation of the circle. Okay, you should now be able to do exercise 6E on pages 126 to 128. Just remember your circle theorems for this particular section, which is where we have a tangent and a radius meet at a right angle. So the radius here, tangent here. And we've got all sorts of things that we know about tangent and radius. Or it could be that we have a fantastic circle there, a chord that meets a radius here, or a line from the center, like that. That's a right angle, and this line inside the circle gets bisected.